All right, so let's look at exercise 12 from section 2.3. So we're given these two piecewise functions, and we're going to be asked a few questions about basically asking us to apply the product and quotient rules. So first is product rule. We're given this function R, which is a product of function P and Q. So P is the blue graph, Q is the green. So first thing we want to do is find R prime of -2. So by product rule, that's going to be equal to what? It'll be equal to P of -2, sorry, P prime of -2 times Q of -2 plus P of -2 times Q prime of -2. So let's fill in what Q of -2 and P of -2 are. So at x equals -2, Q is the green graph. Looks like it has a y value of -1. And P of -2, the blue graph looks like it has a value of +1. What about P prime of -2? That's going to come from the slope of the line segment this is on. Looks like that's going to have a slope of -2. And the green graph is going to have a slope of, looks like +3. So all told is going to be 2 plus 3. The value of the derivative of r at that point is going to be 5. What about r prime of 0? Basically, we can take the same approach. R prime of 0 is equal to P prime of 0 times Q of 0 plus P of 0 times Q prime of 0. So now I'm looking at what's happening at the y-axis. What is P prime of 0? P prime of 0 is going to be most like 1/2, goes up 2 and to the right 4, times Q of 0. What is Q of 0? That'll be 2, plus P of 0, which is -1/2, times Q prime of 0. Q prime of 0, I have a horizontal line segment here, so that derivative is going to be 0. So it all comes out to 1. All right, moving on to part B. So now we're being asked about where does R prime not exist? Or in other words, where is R going to fail to be differentiable? So we know that R is given to us, is defined as a product of P and Q. So really what we have to look for is those points where P and Q are going to fail to be differentiable. So from this graph, that is going to happen precisely where we have these hard corners. Anywhere where we would not be able to define, a unique tangent line. So because of that, our x values are going to be -1 and 1. And since we're only multiplying, those are the only things we need to worry about. There's another consideration we'll have to take into account when we're looking at quotient rule, but for now, these are the points we have to worry about. So R will not be differentiable at these points because P and Q will both fail to be differentiable, and R is defined as their product. So moving on to part C. Now I want to find a tangent line to R, to y equals R of x at this point to R of 2. So, as I've done before, let's kind of use the point slope approach to define this tangent line. So, knowing this is our template, let's find some of this data. The base point of x that we're given is x equals 2. Do we have a corresponding y value? I think that we have found that elsewhere. No, I'm incorrect. We have not dealt with this. So let's do that first. So our y is going to come from r of 2. R of 2, let's remind myself, is it q over p or p over q? Oh, it's p times q. So r of 2 is equal to p of 2 times q of 2. So we care about this value of x. So p of 2 is going to be equal to 2. And q of 2 is going to be equal to 1. So our value of y1 is 2. Now, the last thing we need is to find is that slope. Where's our slope going to come from? Our slope is going to come from the value of r prime of 2. And that will be, because of quotient, or sorry, not quotient, product rule, p prime of 2 times q of 2 plus p of 2 times q prime of 2. So what is the slope of p at x equals 2? Looks like that's going to be positive 2. And what is the slope of, or sorry, not the slope, the value of q at this point? Still 1. We already found this data. We said p of 2 was 2. And last thing we need is the slope of q at x equals 2. So at x equals 2, looks like we have a slope of -1. So we perform this calculation, we get 2 plus -2 or 0. So we actually have a horizontal line. So y minus y1, which is 2, equals 0 times x minus 2. So this will all fall off. So we get tangent line of y equals 2. Horizontal line y equals 2. And finally, part D. Oh, I'm sorry, there are 5 parts to this. So now we're being given a new function z, which is defined as a quotient. We want to find 2 values, z prime of 0 and z prime of 2. So z prime of 0. So we need to use quotient rule here. So let's make sure we got that right. So z prime, maybe we should just deal with that at x before we start plugging in values. Z prime of x will be equal to q prime of x times p of x minus q of x times p prime of x all over p of x squared. So remember, we want to evaluate this at 0. So q prime of 0 times p of 0 minus q of 0, p prime of 0 all over p of 0 squared. So what is q prime of 0? So all this centers at the y-axis, because x equals 0. Q prime of 0. So what is the slope of function q? That's going to be 0. Got a horizontal line there. So 0 times p of 0, which is going to be -1/2, minus q of 0, which is 2, times p prime of 0, which is going to be +1/2, all over p of 0 squared. So p of 0, we said, once again, was -1/2 squared. So we get -1 over 1/4, which is equal to -4. So z prime of 0 is -4. So now let's look at z prime of 2. We can kind of fast forward a little bit. We've already dealt with the general quotient rule here. So z prime of 2 is equal to q prime of 2 times p of 2 minus q of 2 times p prime of 2 all over p of 2 squared. So we no longer care about what's happening at the y-axis. Now we care about what's happening at this vertical line, x equals 2. So what is q prime of 2? So the slope of the green graph at x equals 2 is -1. And the value of function p at 2 is 2. All right, what's the value of the green graph at q equals 2? That's 1. And p prime of 2. So what's the value, or what's the slope of the blue graph? Looks like +2. And finally, over the square of p of 2, which we said was 2. So now we can calculate this. We get -2 minus 2 all over 4. So -4 over 4 or -1. All right, so those are our two values for a derivative of the points we cared about. And now we're being asked at E, are there any values of x for which z prime of x does not exist? So here are two values we know for sure. We know that at x equals 1 and -1, z prime of x will not exist. And why is that? That is because we already know that p and q, the graphs, the functions that are graphed here, those functions are not differentiable at x equals 1. So because of that, z cannot be differentiable. There's one more thing we have to worry about here, and that is, to illustrate that, let's remind ourselves of what z prime of x is going to look like. That is going to be, it's q over p, right? Q over p. So q prime of x times p of x minus q of x, p prime of x, all over p of x squared. So not only do I have to be wary of where p and q are not differentiable, but the fact that I have the denominator here, which can be 0, I got to avoid those times where this denominator can be 0. So let's look at that specifically. Where is p of x going to be equal to 0? Where is p of x squared going to be equal to 0? Well, those are going to be the places where p of x is equal to 0. So that is the blue function. Where is that going to cross the x-axis? Looks like it's going to cross once here and once here. So again, this derivative for z is not going to exist there because we're going to have a division by 0. So these two x values are, so we already have 1 and -1. That comes from the function not being differentiable at those points. But we also have to be worried about x equals, looks like -1.5, -3/2, or x equals 1. Because of those points, we're going to be forced to divide by 0, which is something we can't do.